We've already looked at the concept of stereochemistry, which has to do with the arrangements of atoms in space. So stereo is just the arrangement, and then talking about the structure. So what does it look like in terms of the structure of those atoms on a molecule in space? When we were looking at alkenes, there were certain instances when an alkene had two versions where they look like they might be the same molecule, but the arrangement of the atoms in space did not match up. Therefore, they were two different substances. So we have here 1, 2, 3, 4, 5. So it's 2-pentene. And this also is 1, 2, 3, 4, 5. 1, 2, 2-pentene. So these are both 2-pentene. But these sp2 carbons, this one here has a CH3 and an H as the second and third bonds, and this one has a CH2 and an H as its second and third bonds. And so if you look at a different arrangement, you can see that these are not the same structure. And so when the stereochemistry involved in an alkene was different, when you just moved the location of one of the bonds that you had drawn up to drawing it down, then we end up with two stereoisomers. And we called this one cis because the hydrogens were on the same side of that imaginary line. So that is cis 2-pentene. And this one, the hydrogens are opposite on opposite sides of that imaginary line. So this is trans 2-pentene. But there is another kind of stereochemistry, and it is related to carbons that have an sp3 hybridization. So they have 4 single bonds. And this stereochemistry involves a concept that is referred to as chiral, or you can also call it chirality, depending on how you use the term. So something that is chiral, it occurs when the structure and its mirror image are not superimposable. So, for example, 1-bromo, 1-iodo ethane. So if I draw that, not showing any kind of stereochemistry, then I have my ethane, and on the same carbon, I have a bromine and an iodine. And then I'll also have a hydrogen. And on this carbon, I will have hydrogen, hydrogen, hydrogen. Well, we're not showing any kind of stereochemistry here, but this would be a tetrahedral shape, and this is a tetrahedral shape. And so if we make that structure, here we have the bromo, the purple represents bromo, and the yellow represents iodo. So, and then you have the 2 carbons and then the hydrogens. So if I make the mirror image would look like if you put a mirror up right here, then here is the mirror image. And so these are facing each other. These are facing each other. And then these are both up, and these hydrogens are behind the mirror. The same kind of idea is true for your hand. So if you have your right hand and your left hand, they are mirror images of each other. And so you can line them up, and your index finger, your middle finger, your thumb, your ring finger, and your pinky all line up. But your hands are not superimposable. So I cannot turn this hand and make it completely cover it. Only the mirror image lines up. But if you put them in the same orientation where you can see both the backs of my hands, then my index finger and my pinky line up, and my thumb is over here and my other thumb is over here. So our hands are chiral. Molecules can be the same way. And so this is the mirror image. And so if we look The only way that we can tell if they're superimposable is if we kind of try to put them lined up in the same direction. And so I've just put them on top of each other. And this CH3 over here, it completely lines up. And this bromine lines up. But the hydrogen lines up with the iodine, and this iodine lines up with the hydrogen. And there's nothing that we can do if I want to make the iodines line up. I'll need to shift this over, and now the iodines line up, but the hydrogen lines up with the bromine. I just broke my carbon off, okay? And if I get all three of these to line up, I can't even get them. If I get them to line up, they would have to be like this. And now my CH3s don't line up. This one's way over here, and this one's over here. These two substances are chiral, so they are different stereoisomers. This is predictable if you know what to look for. So if you look at this, you can see that these are sp3. So the first thing, we have to have sp3 carbon atoms. Because they're sp3, you'll have 4 single bonds. To a carbon. Okay, so this has 4 single bonds and this has 4 single bonds. You will have a chiral carbon if the 4 groups attached are different. They have to be different. And so if we look, this is an sp3 carbon atom. 1, 2, 3, 4 bonds. What are the 4 groups attached? Hydrogen, hydrogen, hydrogen. Those are the same. This one is not chiral. This carbon here has 1, 2, 3, 4 things single bonded. There's a bromine, an iodine, a hydrogen, and a CH3. So this carbon here is chiral. The only way to see that they're chiral is if you draw out the structure, and you will need to draw out the hydrogen. So if you do a bond line, you won't be able to see the carbons and you won't be able to see the hydrogen. So you need to be able to see all of these. This is only going to be something that we look at for carbon because the other atoms that are usually bonded have lone pairs. Like nitrogen will have a lone pair if it's neutral. Bromine has 3 lone pairs. Oxygen will have 2 lone pairs and 2 bonds. And so the chiral atoms will end up being carbon atoms, but only if the things that are around it are all different. So if we take a look at this substance here, you'll see right here, this is a aromatic ring, and there's a lot of double bonds. You can ignore any carbons that are involved in double bonds because they are sp2. So it has to be single bonds, single bonds, single bonds, single bonds. You can also ignore nitrogen because it's not a carbon and it doesn't have 4 things attached. This has 1, 2, 3 things and a lone pair. So all of these carbons that are in the aromatic ring can be ignored, but you need to look at each of these carbons that are part of this side chain. So if we look at this carbon here, attached to it is an oxygen. That's a carbon that's attached to a benzene ring. A hydrogen, and this here's a carbon. But this carbon here and this carbon over here are not the same. And so this carbon is chiral. The next carbon over, this carbon right here, it has 4 things attached. It has a nitrogen, a hydrogen, a methyl, and then it has this carbon here with all these other things attached. And so this carbon and this carbon are not identical. So this is also chiral. This CH3, it has 3 hydrogens attached to it, so it automatically will not be chiral. That's called achiral. And this carbon here has 3 hydrogens, so it doesn't have 4 different things. So it's also achiral. So in this molecule, there would be 2 different chiral carbons. In this molecule here, depending on which stereoisomer you actually look at, some versions of this molecule are pseudoephedrine and other ones are ephedrine. It's just the location and the way that the OH and that H are pointed that makes them different. Okay, so how do we show that a molecule is chiral? Once you decide that it is chiral, you have to then show the geometry around the chiral carbon. And so we're going to draw the bromo iodoethane. Okay, so this is not showing any kind of stereochemistry. So to show the stereochemistry, you have to draw it as if it was tetrahedral. And so the parameters to draw this, the way that you do this, you'll put your chiral carbon in the center of your drawing, and then you'll put the 4 things, the entire parts, you'll put around it. So you're going to put one going straight up with just a regular line, and you'll draw one off to the right with a regular line. You'll draw one down below that's angled, but it's going to be a solid wedge. So it looks like a triangle. And then you're going to draw one over here that also is kind of angled down, but instead of a solid wedge, it's going to be a dash. And what this is showing that it's in the same plane as the paper. This one is showing that it's coming out of the paper, and this one is showing that it's going behind the paper. So this is trying to show that it's 3-dimensional. So what you put at the end of each of these bonds is you put one of the atoms that is on that carbon. And so we already figured out that there was hydrogen, a bromine, an iodine, and a CH3. So it's 2 carbons, carbon 1, carbon 2, 1 bromo, 1 iodo. To draw the mirror image, this is the way that I do it. I draw an imaginary mirror, and then I draw a reflection. And the way that you draw the reflection, whatever is closest to the mirror will be closest to the mirror on this side. And so closest to the mirror is bromine. And the direction or the kind of bond will stay the same, but it's not going to be pointed this way. This one's pointing to the left, so this one will be pointed up to the right, to carbon. Okay, hydrogen is still going to be going straight up. And then we have this iodine, and I have it pointing down to the left, or the mirror of that would be down and to the right. Because it's pointing away from the mirror, so away from the mirror. That's iodine. And then this one is kind of behind, and so it's pointing kind of a little bit down and to the left. So it's going to be pointed a little bit down to the right. But that would be the mirror image of that. So what I want you to practice are these two skills here. The first thing, question number 1 in chapter 4, that's on page 155. I think this one's 157. This one's 157. 155 gives you a name, and you want to draw it like I drew our first one, and then look at the way you drew it and look at each carbon that has 4 single bonds and see if the groups that are attached are identical or different. If all 4 things are different than each other, that carbon will be chiral. So you want to draw those and find any chiral carbons. And then number 2, which is on page 157, what you want to do is you want to draw it in your notebook. So that it's already in your notebook. You want to draw each of them. There's a B, C, and D. I want you to go ahead and draw it. Well, just do A, B, and C, A through C. Okay. And then right next to it, leave space so that you can draw the mirror image. And so go ahead and draw the image as you see it in the book, and then leave space right next to it so that in class we can practice drawing the mirror image. What we're going to do is we're going to draw the mirror images, and we're also going to figure out how to distinguish which one is which. So the way that we tell which one is which is we look at our drawing and we assign priority. And we're going to assign priority the same way that we assigned priority for our cis and trans, or not cis and trans, but the E and the Z. And so you look at the 4 things, and whatever is directly attached, you look for the one that has the largest or highest atomic number. And so that would be first priority. So iodine, its atomic number is 53, bromine is 35, carbon is 6, and hydrogen is 1. So iodine would be the first priority. This bromine would be second. The carbon is third, and hydrogen is fourth. So for the molecules that you draw in number 2, you want to look for the chiral carbon and look at what's attached and assign priority. Number 1 is the highest all the way to number 4, and go ahead and label them 1 to 4 on your drawing. And then once we draw the mirror image, we can number the mirror image the same way. And then we're going to take our newly drawn mirror images, and I'm going to explain how you can determine the name of this one so that it shows that it's a different substance than that one. And so for your homework, just identify the chiral carbon, draw the structures as you see them for A through C, but leave a space next to A to draw the mirror image, next to B to draw the mirror image, and next to C. And for the groups around the chiral carbon on A, B, and C, number the priorities 1 to 4. Then upload that into Moodle.